Hi guys, I am Yogesh from Professional Training Institute, and today my friend Dhanraj will tell you about transformer. Okay, so ask question, type here, we will see. Okay, thanks. Dhanraj.
Transformer is a static device which is used to deliver electric power from one circuit to another circuit. These transformers are used in lot of applications. The major applications are step up and step down purpose. And transformer is working with the Faraday's electromagnetic induction law. That is, when a conductor is placed in a change in magnetic field, it will induce some EMF into that. So let's check what are the compounds in
What is EMF?
electromotive force. That is voltage.
It is induced.
Yeah, induces to the conductor. Transformer is a static device because the electromagnetic field is everything is fixed. Nothing is changing. Only changing is magnetic plus. Magnetic plus is only changing. So in some case, some areas in electromagnetic induction itself, we have to get electromagnetic induction. We are changing the conductor. We have fixed the magnetic flux. We can change the conductor also. Here, consider an ideal transformer. Ideal transformer means there is no loss. Loss due to the resistance of this material. In here, I am applying alternating current. Alternating current means it's flowing like that, positive to negative, positive to negative. Here, if a current is flowing through a conductor, it will. If current is flowing through a conductor, it will generate a magnetic field surrounding. So, if I take the conductor and I coil this way, and the magnetic field intensity it will be higher in this. If I coil like this, it can store the magnetic field, and I connect like this. So this is AC supply. If I connect the core to this conductor, the magnetic field will be generated. Because this is an alternating current, it will induce some magnetic flux into the core, and it will reach here. It will reach here, and here the same magnetic field by what I applied in this input. The same magnetic field will appear here also. This is a metallic body can conduct a magnetic property. So same magnetic field will reach here. So the magnetic field itself changing because I applied the AC current. So it will change. It has positive and negative. So it will change. So it will cut the conductor, and it will induce some EMF here. If I want, this is actually happening. This is the principle of transformer. This is actually electromagnetic induction, Faraday's electromagnetic induction. If I want to increase the voltage, if I want to increase the voltage in the secondary side, I have to increase the number of turns. If I increase number of turns, and more number of fluxes will cut in the load.
Okay. How transformer works, Chetna? How transformer works?
Alternative current is given in the primary section.
Do you know what he said? He said electric field.
Yeah, in a conductor,
So it generates magnetic field only. Yeah, go on. After that,
and it will circulate there, and it will generate electric, that is flux.
flux. Okay, what will happen after that?
Then it will,
How flux will go to secondary side? Did he explain? No? He explained properly.
how it will go.
Yeah, what will happen? How transformer works? I want to know. He is explaining. No? Prabhu, how transformer works?
Electric current, the alternating current is passing through the
You check he is saying right or wrong.
alternating current is passing through the magnetic field directly.
It is flowing through this conductor. If the current is passing through a conductor, in surrounding itself, it's generating magnetic field, magnetic flux. It will generate. This is a,
So that flux is carried
this is
core.
core is metal, a metallic.
Flow.
If I take a metal can conduct current. If I touch a magnet, it will attract magnetic flux. Same thing is happening here.
Core is not a metal. Core is a ferromagnetic material. It's a special type of material.
Its resistance is very less.
No?
Resistance is
It's a ferromagnetic material, not metal. Yes, sir.
What is difference between metal and ferromagnetic?
No, ferromagnetic material is not a conductor.
Just it attracts the magnetics.
Yeah,
That's
it-
what it generates. That will be.
It attracts the flux, it won't attract the current.
Correct. That flux is passed.
So ferromagnetic metal is not a conductor.
It's not a metal.
Not a metal, it's a,
No magnetic.
it attracts the flux.
ferromagnetic,
In the
not metallic, ferromagnetic. It can conduct magnetic flux.
Flux it can conduct.
Flux can be passed.
Yeah,
Then-
yes, Prabhu, go on.
So both sides in the magnetic flux can connect
No, how it works you have to tell, no question. Question time is over.
So alternate current is passing through the core and it will produce on the way magnetic flux.
Yeah, that is happen in primary side. What will happen at secondary side? You ask to him if you have result. Ask properly, now what secondary?
After the secondary, what current will be?
This is a ferromagnetic material. It can conduct magnetic flux. So the same flux will be generated here. This is an alternating flux. That is, what we are giving input AC input. AC input is alternating current. So the flux itself alternating.
Yeah, what happens if we flux will be come here?
Hmm.
It will be.
Flux will cut.
Correct.
It is alternating. It's changing. It's not constant. It's going higher and coming downwards, and will be coming to zero and will be higher, and that will cut. Actually, the field strength will increase and decrease. Field strength. That's why the conductor is cut. If it is constant, nothing will happen.
If you want more, you are giving less current and you want more. Then how this will be like secondary will be gives high current.
We can increase the number of turns.
If
Number
you
of
increase
number of turns, then the high flux is same. If I giving what input I am giving, the same flux is generated here. The same flux will I get the output side. If I increase the number of turns and the flux, then the number of flux, not flux, number of turns increasing the number of cutting of flux. Flux will cut more.
Because of the fields.
Yeah, because the number of turns.
In secondary, there is more number of turns. In secondary, there is
Number of this is actually step upping. If we want number of voltage is higher, we want to increase number of turns.
So if we increase number of turns, then it will be step up or step down.
Step up.
So in your first example, it was step down or step up?
This is step down.
Yeah. Can you explain? Prabhu is saying something else.
Initially, usually it's a step up.
You want to step up, you have to increase the number of turns.
Step down, we have to increase the turns.
Yeah, if flux, you said the flux will be cutted. If flux is cutting, how the voltage will increase? How, what will produce? AC input we are giving less and we are getting high in step up. So you said that in secondary time that flux will be cutting to get more. How it will be? If it cuts, but how we will get out?
Yes, I will check.
If the flux is cutting with respect to number of coils,
Number of turns.
number of turns in coil, secondary coils. So if the coils number is less, then the flux will be reducing in that secondary coil. No? So is the EMF generated in secondary coil will be less.
If I increase the turns, it will be higher.
It will be higher.
Higher EMF voltage.
Yeah. Voltage. Okay.
In primary side you give AC input.
Yes.
What you get in secondary?
Same AC.
Same.
AC.
Same input.
Yeah. Same AC I will get.
You get same voltage.
No. Voltage will be different. For that I am using. We want to change the voltage. Input voltage I am giving, and I have to get if it compare with decrease or increase. I want to.
Output of the secondary will be the difference in voltage. Secondary section.
Current. No. It will be different. Actually, it will be different. Current is also different.
The same current is transformed. It's not
No conversion is doing. Just changing.
just taking from one source to
One source, one communication at a time. Everyone listen and then ask next question. Everyone is asking important question, but nobody listening each other. Yeah, go on.
She asked, I will tell you that same question she asked.
Yeah, ask question again. No need to stop. Ask.
What is the use for this transformer?
In rectifier we are using. We did the experiment. In step down we are using.
How would you use?
That is, if you want to operate a circuit with 12 volt in analog to digital, analog to digital. If you want to in power grid, in power communication, that time in outside transformer their input is 11 kV. In home appliances, in every component fan we can say 230 volt or power rating will be there. So from 11 kV we can't apply. It has power rating. Power rating will be there. So that we are using 230 volt power rating. So we want to decrease 11 kV. Each and computer component has their own power rating.
So we will reduce 11 kV voltage from primary section to 230 voltage in secondary.
Secondary. So that we are using step down.
Step down.
In some cases, in between the power grid, they are using step up transformer also. But I don't know where it is using.
What about current?
Current will also change, sir.
Yeah. How? It is steady current or not?
Sir, I know some equations, sir. Actually, if 230, actually it depends on power. The same power I am applying,
Very good.
the same power in the secondary
This is
side.
the key of that. Don't forget what he said. Yeah, go on.
What power I am applying, the same power will be here. Power is equal to VI. If I am applying 230 volt here and I am applying the current is
5 ampere.
5 ampere, then the output here I am getting 12 volt. Then there is a formula V1 by V2 is equal to IQ by
No, you calculate power in primary 230 into 5
230 into 5,
into 5.
100, 180,
Yeah, right what?
100, 150. Okay, this is the power. The same power I want to get in the secondary side also. If the voltage when I using step down transformer, I am getting 20 volts. So if I want the power, I am
So
getting
what will be the current at secondary side? Who can tell?
Power is same.
Yes, power is same. Output is getting 20 volt.
1150 divided by 2.
that this is 12 volt. This is the current I have to get here. Power should be same. For subcons. I just for complex, okay, 12 volt, 15 volt, anything.
So this is 120. Here you put 20 volt at the secondary side. That's 150 divided by 20.
20 current power will be same.
Here we can changing any frequencies.
Yeah, same frequency, 50 hertz. We are not changing the frequency. The 230 volt in normal appliance is in your input is 50 hertz. The same frequency will be there. TMC frequency is in 1 second. How many signals are going? In 50 cycle will go in 1 second.
So if we are making one transformer, we should take care of this number of coils.
Number of coils. Yeah, turns.
So in our demand, we need 230 volt in primary and we need 12 volt. So how we will find out how much coils we have to put in primary section and how much we have to put in secondary section?
How many turns we have to take? Like,
This is the formula for
number of
turns and
Voltage.
voltage. V1 is
230. By 12. Output is 12.
okay. We can consider N1.
Okay.
And one is always one.
So
That's the wrong. That N1 is 230 volt. This is also a step down, and N2 will be less
less.
in that side.
Okay, but
I think there is another kind of formula to find out a EMF induced in the secondary side. 5.
Yeah, that's okay. No need to find EMF, but yeah, any doubt? Yes. Hey, I am again Yogesh. Yeah,
So if I want to make one transformer,
Okay.
I want to build.
okay.
So my need is input is 220 volt and output is 12 volt. So how can I calculate primary section call number of turns and secondary section number of turns?
Okay. So output what you want? Input is 230 volt, right? And output
12 volt.
12 volt. Can I take 23 volt?
Yeah.
Oh, no, it will help me.
Yeah.
Just divide 23 here. So
10.
it became 10. Okay. So input and output turn ratio should be 10 times. If you primary side, if you are putting 100 turn, then you put 10 here. If you are putting 1000, then you put 100.
From that ratio. So that ratio should be we take care of.
See how it is, I will tell you. I'll give one analogy. Okay, consider I close the door, close the window, everything I closed, and I flow the water here. Okay, and now you have to drink the water. Okay, so how much water? Not through glass or something, directly like monkeys drinks or dogs drinks like that. So whatever water you can drink, whichever you are having capacity, that's all. Yes? No?
Yes.
Okay. Same thing is here. Primary side we give input voltage and flow the flux. Okay? And output side, in the secondary side, we put the monkeys to drink the flux. Whoever drink more, if he is drinking same coils, then he will get the same voltage output. Making sense?
So if it's the ratio 10:1, then I can give 400 or 40. I should keep up that ratio only. 10:1.
Yes. No, what is your question?
Question is that the same one only. So we don't know the primary number of coils and we don't know secondary number of coils. So but we know the ratio.
Yeah, ratio should be same.
Ratio should be same. The number of coils is doesn't matter. I mean, if I am giving 400 in primary, 10:1 is the ratio. 400, then here I am giving 40.
Yeah,
It's okay.
it's okay.
So for everyone, you give 10:1.
No. Output voltage. She wants 23 only. Earlier she wants something else, then I influence her and I change. Yeah. Any doubt in this?
And that metal part, no? Ferromagnetic coil part. That also how much we have to take?
As maximum as possible.
So sir,
As maximum as possible. As bigger as possible.
then it improves quality.
It
If I am
improves the
giving
quality.
more, it will improve the quality.
Yeah. Because when I am flowing the water, that water should be maximum through this only. It should not flow through here. If some of the water flow through here, like if I flow the water and some goes out, you cannot drink that water.
So what is the difference between magnetic and ferromagnetic?
Good question. I don't know. Ferromagnetic materials are, I think that irons are having some like ferromagnetic properties. So what is that ferromagnetic properties are? Those are more attracting by the magnetic fields. They are not attracting toward the electrical field or electric current. So for electric current they does not have any sensitivity, but for magnetic they have. Exactly, I don't know. Okay, so there is lot in the transformer. It's not only this. Consider this is the coil and this is the input side and this is the output side. Consider I am having 1:1 transformer turn ratio. Here I am giving 230 volt and here also I am getting 230 volt. Any doubt in this? Yes, no?
No, sir.
Okay, one more coil I put, that is also ratio 1. So here also I am getting 230 volt. Okay. So input I given 230 volt, but output I am getting 230 volt. What is that? It's made coil, right? See, if I am having 100 ton here, I am having 100 ton here, I am having 100 ton here. Yeah, he will also get 230 volt. He will not. Any doubt in this? But how it's possible? One input I am added two input. How it's possible? So what is important point here is he already told.
So only we get one of
Power should be same.
Power should be same. So whatever input, consider if it is a 100 watt input, so both together will be 100 watt. It's not like he will also get 100, he will also get 100. Okay?
The voltage is same, then we will not
Voltage is same, but current capacity he won't have. Consider if he is having a current capacity of 5 ampere. So both together can draw maximum 5 ampere, not more than that.
This is for 1:1 number of turns. Unity 1:2.
Then also power will be same. Current can vary, but power will be same. Voltage can be different. That's why if you see the SMPS power supply in the old PCs, had you anybody seen SMPS power supply? Nobody seen? Can you bring one computer is there? That Bhagwanji below the Bhagwanji. We are keeping water na? Downside of PC. Okay, if you see the power supply, there are so many wire coming out, and they are example of this. Okay, although those power are, some of them are the DC outputs, most of them are DC output, only one or two is AC. Okay, so DC, we are not talking of DC. What will happen if we give DC input here? Hmm? Magnetic field will not generate, it won't work. Transformer action won't work. What we have to do in that case? In that case, we have to give pulsating DC in an input. In an input side, we have to give this kind of signal. That is separate, altogether separate thing. But I just want to touch.
The magnetic we want it.
Yeah, here it is. That's one. Not heavy. 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 See, this is the power supply. This is the power supply of computer. Every computer is having. And see how many bunch of wire is coming out of this. It's there. Able to see? So many wires. Most of them, these wires are, you can see here, the current rating and the output power is also mentioned. But they all are DC outputs. All are DC. No AC output. But similar kind of thing we can have here also. That is what I am saying.
But here it is AC inputs.
The same transformer works with pulsating DC. Same transformer. So it is like same as AC, pulsating DC.
No, there are many things to discuss. It's a complete whole new topic. It is SMPS. Switch mode power supply. Whole new topic. It's not a, I cannot finish here if I open thread. Okay? Any doubt in this? Fine. The biggest advantage of transformer is isolation. That is the magic. Okay? Isolation means input is not connected with output. And if input side some burning happen, then also output side not at all a problem. This is the biggest advantage. Okay? So I could show, after this class, I could show you some adapter, some good kind of adapter. If you open and see some costly adapter, they are having the isolation. Isolation means wherever they put the transformer, the PCV, what is this dot? This will be hole in the PCV, and here PCV will be slit. Slit means cut. If you see the PCV, consider this is the PCV, and if you are putting transformer on top of this, consider you are putting transformer on top of this, so this area will be cut, literally cut in between, because we don't want anything to be transferred from here to there. Although nothing is going to transfer, this is just PCB, signal is transferring through transformer, but inside the transformer also one coil, see this is the one primary coil and this is the secondary coil, and they wrap like this. Even though primary and secondary are wrapped like this, they are not touching each other. You will say, sir, they are touching. No, they are not touching. They are immunal coated. They are coated such a way that wire is a special type of wire. Even though you touch it, it's having a coating on top of it, immunal coating. Okay, so you see they are touching, they are not touching actually. He is having some special coating and he is also having coating. That's why in our home, when our washing machine not working or geyser not working, then we say motor got burned. Did anybody observe? Or our sump motor not working or any motor not working, we say motor got burned. What it got burned is this wire and this wire got, that coating got over and they got short. When they got short, so whatever output you was expecting, that you will not get. You will get some other output. It may be more, it may be less. I don't know where it got short. Making sense? Okay, so the biggest advantage of transformer is isolation, and for that purpose we use transformer.
Only isolation.
No, apart from that, step up, step down, all those things is there. Isolation is the biggest advantage. You know that Samsung wireless charging?
Wireless charging.
Wireless charging. What is that wireless charging? No. Okay, you don't know, but have you seen that advertisement or something?
Wireless mobile charging.
You seen, right? Yeah, how it is, how it works?
You are using one antenna, one antenna.
No guys, not seen. See Samsung mobile, this is Samsung mobile newly launched. Hey guys, if you not seen, have a look. So new Samsung mobile launched, and if you want to charge wirelessly, they are having a one pad like that. Just keep it phone like this, it will charge. Not immediately, over some 1 hour, 2 hours. And then you take it and you no need to plug the wire inside. This is of course connected in the wire, connected in the power source. This is your mobile. And you want to charge, just keep it, select, take it, works. So it will charge. Yeah. How did it charge? It's this transformer. So one coil is inside this, one coil inside this, and they are transferring power like that. Isolation.
If they are in contact, then only it will charge.
Yeah.
If we are putting beside.
Yeah, little away, how this power will transfer.
Physical contact, yes.
Yeah, but the plastic is there. You cannot, you still amaze. Uneducated people still amaze. So you people can amaze. I am not. I know what they are doing. So they are having one coil, we are having another coil. They are just putting like this. Let's say they say wireless charging. People say, wow, I'll give 20,000 extra. Okay. I don't mind to give, take 2 rupees wire, 20,000 extra. Eh?
Apple's next phone also having.
Wireless charging?
Yeah, I have seen one advertised too. But
Hmm.
they are keeping some far away from the charger.
Hmm.
And starting that they demo advertisement. That advertisement.
They may using some other technique.
Because
Because nowadays people are talking based on the RF fertilization people are talking. See, our phone is keep getting RF signal. People are talking to generate power on that RF signal. I don't know which technique they use. Find out and let me know. Okay, in transformer, any question? Power up, power down, power, current, flux, magnets, primary, secondary, isolation. Yeah, that's all pretty much for transformer. Okay, transformer is one of the important device. And whatever we discuss here, we discuss about the ideal transformer, which is not possible in the field. What is happening is, whatever power input side we give, input power, and whatever we get in output power, that there is some difference, and that difference is the losses. There are thousands types of losses, eddy current losses, hysteresis losses, like that. I don't want to go inside those things. Okay.
Outside or some transformer using outside.
Yeah.
Sometimes I saw, sometimes it burn.
Okay.
How it will burn?
No, it's overrating. Normally in our outside the load is more. When load is more, then it got burned. You are loading more on the secondary side, but transformer is not rated for that. It will definitely burn. Okay, thanks for watching. Stay tuned. One more has to come. Yeah.